Welcome to Module 3 of the Introduction to Polio and the GPEI course. In this section, we will explore the differences between the two polio vaccines and learn how herd immunity contributes to prevention. We will also introduce some poliovirus definitions, look at how poliovirus is diagnosed, and then provide a brief overview of outbreak response actions. Prevention of polio is possible through immunization. There are two types of vaccine. The inactivated polio vaccine, IPV, developed by Jonas Salk in 1955, and the oral polio vaccine, OPV, developed by Albert Sabin in 1961. Both vaccines are still used today and both are critical for polio eradication. We'll go through the advantages and disadvantages of both vaccines now. Oral polio vaccine, or OPV, is a primary tool used to eradicate polio. OPV is safe, cheap, effective, and easy to administer by just 2 drops of the vaccine delivered orally. OPV contains attenuated or weakened polioviruses. The viruses used may be polioviruses types 1, 2, or 3. The different combinations of vaccine are known as monovalent, bivalent, or trivalent OPV. OPV acts by mimicking a natural immune response following infection from the virus. The live virus in the vaccine stimulates both humoral and mucosal immunity. Humoral immunity prevents the poliovirus getting to the central nervous system, protecting the individual from paralysis, while the mucosal immunity limits the replication and thus shedding of the virus. As both individual and passive immunity in the community is created, the OPV vaccine has the ability to interrupt transmission of the poliovirus in well-immunized populations, as there will be a limited period of virus shedding and no susceptible hosts for the virus. Bivalent OPV is currently used in nearly all polio vaccination campaigns worldwide. The inactivated polio vaccine, or IPV, is an injectable vaccine that can be administered alone or in combination with other vaccines. IPV is over 5 times as expensive as OPV and must be delivered via injection from a trained health worker. It consists of inactivated or killed poliovirus strains of all 3 poliovirus types. IPV is able to stimulate humoral immunity much more effectively than OPV. However, it only induces a limited mucosal immunity. Therefore, it is extremely effective in protecting children against paralysis, but is much less effective in preventing replication and shedding if the vaccinated individual is exposed to the virus. Unlike OPV, it is not able to help interrupt transmission of the virus. However, if IPV is received after an OPV dose, this can further increase immunity against the virus. Since November 2014, countries around the world began introducing at least 1 dose of IPV into their routine immunization schedules. Here we invite you to watch a short video explaining the difference between the 2 types of vaccine.
Polio is a disease that causes permanent paralysis. We can't cure it, but we can prevent it. 2 important tools help to prevent polio, 2 safe, effective vaccines. One of these vaccines is given with just 2 drops into the mouth of a child. This is called the oral polio vaccine. The other is given with an injection. This is called the inactivated poliovirus vaccine. They both teach children's bodies how to fight off the poliovirus, but they do this in different ways. The oral polio vaccine builds protection in the child's intestine. This vaccine not only protects the child who receives it, but also protects others around the vaccinated child. Several doses of the oral polio vaccine should be given to every single child in places where polio is a threat. The injectable vaccine builds protection in the blood instead of the gut. It helps to boost immunity and keeps countries free from polio. But it doesn't stop polio spreading between children, so it is not as useful in places where the virus is still circulating. We need the oral vaccine to stop the virus wherever it is found. Once polio has been stopped everywhere, the inactivated poliovirus vaccine will be used on its own to keep populations protected. Both of these vaccines have been approved as safe and effective by the World Health Organization. To do their job properly, they need to be given to all children, no matter where they live. Thanks to these vaccines, cases of polio have fallen by over 99% around the world. Let's vaccinate every last child. Let's end polio forever.
Remember from the previous slide that each vaccine type has both advantages and disadvantages, and both play an important role in the global polio eradication initiative. The key to polio eradication and polio outbreak control is herd immunity. Herd immunity occurs when a significant amount of the population is protected through vaccination against a virus, making it difficult for the virus to continue to spread. It is important to reach herd immunity to protect those who can't get vaccinated, like immunocompromised children. The blue dots indicate a person who is unvaccinated. The yellow dots indicate a person who is vaccinated. The red colour represents poliovirus spreading through the particular community. The top row, indicated by the 0%, 25% and 50% vaccinated boxes, is low levels of vaccination. It enables the virus to spread and reach all susceptible and unvaccinated individuals. Medium levels of vaccination, indicated by the 75% vaccinated box, slows down the progression of the virus, but it is not interrupted and will continue to spread to susceptible and unvaccinated individuals. Once you reach a high enough level of vaccination in the population, indicated by 90% and 95% vaccinated, the poliovirus gets effectively blocked from spreading any further. It cannot spread because it encounters too many vaccinated individuals, and so the majority of the population, even the unvaccinated people, are protected. As mentioned earlier, OPV has a unique ability to build individual and passive immunity, helping us reach herd immunity and interrupting transmission of any poliovirus. When vaccination rates decline, herd immunity can break down, leading to an increase of people being exposed to and transmitting poliovirus. Let's now take a closer look at types of poliovirus. First, we have wild poliovirus, or WPV. It is a naturally occurring poliovirus found in 3 variations, types 1, 2, and 3. Then we have the Sabin or Sabin-like virus. This is a weakened virus used in OPV vaccine and commonly found in the environment after vaccination campaigns. In under-immunized populations, Sabin-like viruses from the OPV vaccine can continue to be transmitted from person to person over an extended period of time, providing passive immunity. In some instances, after an extended period of circulation of Sabin viruses in many under-immunized hosts, the weakened virus from the OPV vaccine can diverge genetically and become a vaccine-derived poliovirus, or VDPV, giving it the ability to potentially cause paralysis. Transmission of vaccine-derived poliovirus, based on multiple detections of viruses in individuals or the environment, is considered to be a circulating vaccine-derived poliovirus. Circulating vaccine-derived polioviruses pose the same public health threat as wild polioviruses and have the potential to circulate further in communities where poliovirus vaccination coverage is low. Finally, we have vaccine-associated paralytic poliomyelitis, VAPP, which is an adverse event associated with OPV vaccination, occurring in approximately 2 to 4 cases per million birth cohort. People with immunodeficiency are at highest risk of susceptibility to VAP. Here, we invite you to watch a short video that provides more detail about vaccine-derived polioviruses.
Polio is an incurable disease that can cause permanent paralysis. Thankfully, there's a very effective vaccine known as the oral polio vaccine, which provides lifelong protection from polio. Each drop of the vaccine contains a weakened form of the polio virus. This helps the body to develop immunity so that the child is protected against polio. Just like the wild polio virus, the vaccine virus can be passed from child to child. This helps spread the protection against polio to other children, even those who aren't vaccinated. However, When a large number of children are not vaccinated and immunity levels are very low, the vaccine virus can continue to spread from one unprotected child to another for a long period of time. As the virus continues to find unvaccinated children, it undergoes small genetic changes. On very rare occasions, this can cause the weakened virus to change into a form that can cause paralysis. These rare virus strains are called vaccine-derived polioviruses. They can paralyze people for life and can even spread to cause outbreaks. This is called a circulating vaccine-derived poliovirus. If immunity is high, vaccine-derived polio cannot arise. That's why it's so important to reach every last child with vaccines. If outbreaks do occur, they can be stopped in the same way as wild polio, with vaccination campaigns that protect children against all types of polio. To eradicate polio, we must stop all types of the virus. Let's make sure we vaccinate every child and end all polio for good.
Let's now look at diagnosis. Since other neurological diseases may have similar symptoms as paralytic polio, for example, Guillain-Barré or traumatic neuritis, laboratory confirmation is critical to establish the diagnosis of poliomyelitis. First, a virus isolation is needed from stool samples. A cell culture will then be conducted to determine whether the virus is type 1, type 2, or type 3. Then, intratypic differentiation is conducted, enabling identification of wild poliovirus, vaccine-derived poliovirus, or Sabin, the vaccine. Intratypic differentiation is a diagnostic method to differentiate the type of poliovirus by polymerase chain reaction, or PCR. Finally, genetic sequencing then allows identification of the geographic and temporal origin of the virus, which includes the approximate age of the virus and its relationship to other viruses. Genetic sequencing is a sophisticated diagnostic tool that has enabled scientists to build a database, or family tree, of polioviruses worldwide. This database has provided critical insight into virus location and transmission pathways, often consistent with population movement. This enables polio outbreak response teams to develop rapid approaches for responding to polio outbreaks and building immunity in susceptible populations. All polio events and outbreaks require immediate action, including investigation and risk assessment. However, events and outbreaks are defined differently and may trigger a different set of actions. An event is defined as a single isolation in an individual or the environment with no evidence of transmission. An outbreak is defined when multiple virus isolations occur in individuals and/or the environment, indicating that there is evidence of transmission. Depending on the determined level of risk, a series of outbreak response activities will be conducted. Once again, all polio events or outbreaks require an immediate response. The ultimate goal is to stop all outbreaks within 120 days. As a result, a rapid response is crucial. Within 24 hours of a virus notification, an epidemiological and social investigation should be completed. This should examine the case or environmental isolate, the local context, and determine the geographic extent of transmission. Within 72 hours of virus notification, a detailed risk assessment should be prepared. It should outline the virologic risk and the risk of international transmission. And from 14 days onwards, depending on the level of risk, response activities are initiated. These include communicating the risk and social mobilization to inform affected communities, immunization campaigns to vaccinate children, enhancing surveillance to help health workers to recognize symptoms and identify new cases, and strengthening routine immunization to ensure children are vaccinated. You have now completed this module on polio vaccines and key polio definitions. In the next module, we'll discuss the GPEI partnership and the status of polio eradication. First, try the end of the module quiz to recap what you have learned.